Okay. Yeah, so last I checked, we have about 68 A1s submitted. So I think I've contacted most people. If you don't have that submitted, just let's try to get that in as early as we can. Set up time with the TA. We still have that lovely office hours channel going, and I know there are lots of people who are just ready to help. So don't be afraid to reach out. Or I guess I could expand upon ways I could help out. We could set up in a meeting to make a catch-up plan. I've had a few people with technology issues, and I want to remind everybody that if you are having issues with your primary device, with your laptop or your desktop, we can provide a temporary loaner laptop so that you have something that is actually working that you're coding on. It's always nice, right? And just feel free. I would encourage everybody to drop by on look for the office hours in TA rooms. Well, look for the office hours in the office hours channel. There's that spreadsheet, right? At the very top, TA office hours. And there is almost certainly a TA whose schedule aligns with yours. If you're having difficulty getting through an assignment, just pop in there. It doesn't have to be your TA. I know a few people have gone through with office hours that are just completely empty. So definitely worth the pop in. And if you don't feel comfortable popping in, you can always message the person beforehand. But I definitely want to encourage people to reach out if they feel like they're struggling with Java at all. And just want to remind everybody that the program was intended for people to reach out and to get some guidance on this stuff. This is a lot of material that we're covering very quickly. So yeah. What else did I have? I think that was it. Oh, no, that's not it. So one of our floater TAs, he had a brief contract with us, TA Aaron. He is departing today. So if you've had a chance to interact with TA Aaron, make sure and tell him thank you and just wish him well. I think he'll probably still be around in Slack, but thank you, Aaron, so much for coming in and helping us out when there was a vacancy, and hopefully we'll see more of you in Liftoff and later on. And that is all for my announcements.
Okay, everybody, get into this game if you want to participate. We're going to start in just a second. Okay. Get started. Join, so you can still join real quick if you want to and get in on this question. All right, true or false? Inheritance allows you to pass fields from one class to another, but not methods. That it's absolutely false. Yeah, both fields and methods get passed along. Great. Multi-select. What are alternate names for a parent class? Great job. Base class and super class. Yep. All right. True or false? The extends keyword is used to designate inheritance from a base class. True. Extends is the correct keyword. Great. All right. Got another multi-select here. What are alternate names for a child class? Great. Yep. Subclass and derived class. Awesome. Okay. True or false? The super keyword can be used in both the subclass's constructor and in other methods to access inherited methods. True. Good job. All right, Matt jumps into the lead. True or false? If you use the override annotation on a method in a subclass, it must have the same signature as the base class's method. True. Good job. Beignet in the lead. All right, quiz, multi-select. And this one's double points, which are not true of an abstract class. All right. Yeah. So you cannot instantiate objects of an abstract class. So it is not true that you can. And the reason I gave you guys double points on this is because of the other one that is correct. An abstract method actually can be used as both a base class and a subclass. You can have multiple levels of inheritance with abstract classes and kind of break things out a little bit before you actually start getting to your regular classes that you can instantiate things from. And we didn't talk about that before. It was kind of a little, surprise thing that I threw in. So for those of you who got those right, great job. But that was tricky. All right, puzzle. Put the sections in the right order for diagramming a single class. It should be easy. Yeah, good job. Class name, then fields, then methods. It reflects the same way that you would lay it out in the code. Okay. Which is not a common convention for the unified modeling language. Yeah, good. So the other three are the correct ones, but you actually use plus sign for public and minus sign for private. So that's why that one's not correct. Okay, Amy goes into the lead. Last question. In a diagramming a relationship between a base class and a subclass, the arrow should point to the subclass. Yeah, that's false. The arrow actually points toward the base class. It points upward in the inheritance. It says, this is the one that I'm inheriting from it. That's the direction it points. I know it seems counterintuitive to me, but this is in fact the way it's done. Okay, here's the podium. Third place, NW. Great job. That's a great job. J rolls in second place. In first place, we have Amy. All right, so I'm going to close out of here. All right, and we're going to go on to our lecture. We're going to talk about interfaces and polymorphism. There's a couple of things that, well, I'll get to in a second. Yeah, we have a standard format today, so lecture and then studio review. After studio, that is. So announcements, again, this is the same thing as before. Liftoff Q&A, as Colin has reminded you as well, will be next Thursday. And the deadline for grade assignment 2 is after that catch-up class on Monday the 13th. And I wanted to point out that you now know everything you need to know to do this. So, if you haven't already started on it, get started. Okay, so we're going to talk about this topic of interfaces and polymorphism. And what I was going to say before is that there's actually some of this that was covered a little bit in chapter 7, but then I didn't include it in lecture last week because we had so much to cover. So I've kind of just decided to lump it in with what we're doing today. And that includes casting, talking about the polymorphism with classes and then how it works with interfaces. And we'll talk about kind of what are the differences between an interface and an abstract class, because that can be kind of confusing at first. Unit testing with interfaces, and then also how to use the IntelliJ generator yet again to make your life easier for implementing some of this stuff. Okay, so polymorphism as a general concept just means you can have objects that are of different classes, but they can have some common behaviors. And so you can actually use those objects, even if they're different kinds, you can use them in the same way. So with class inheritance, you achieve polymorphism using casting. And I'm going to give you an example of that in a minute. But interfaces actually offer a way for you to define some set behaviors and require that these classes use them no matter what classes they are. And they can be completely different in most other aspects and yet still have to, have these behaviors in common. So it's very useful. And we will see that in a minute. So this idea of casting, you've seen casting once before when we were setting up, let's see, it was when we were setting up the overriding on the equals method, if you remember. And, you have to start with something as an object, like a generic object, and then you cast it to that class once you determine that it is of that class. And, but this idea is that you can actually have objects of a subclass that are given the type of the base class. And then there's certain methods you may not be able to access directly. So then you have to use casting. So we have this base class type here, book that is instantiating a used book called Fahrenheit 451. And if you try to do this, condition here where you just, call get condition, because condition is one of the, you're going to see these classes in a second, I promise. You try to get that, go get the value of that property using the getter that belongs to used book. It actually won't work because that does not belong to book. It belongs to used book. So you can't do it that way. But what you can do is actually use this casting to cast Fahrenheit 451 to used book, and then take that casted version of it and call get condition. So that's, I say it that way because you'll notice there's a lot of parentheses there. You have to wrap the entire thing in parentheses before you call the method so that it casts it first and then it calls the method. You won't see this a ton probably, but every once in a while you'll have cases where maybe you have a method that takes something of the parent class, but you can pass, and your book gives a good example of this, you can pass something of a subclass into it, but then to access certain things, you might need to do this casting to make it work. But that's the idea, is that, they can operate very much in the same ways because they have these things in common. But as I said, if you have two completely different unrelated classes, interfaces is the way to go, because you can make this blueprint for behaviors. And you just have to keep in mind that interface is not a class. Okay, you can't instantiate objects from an interface. You just specify a set of behaviors. So this is focused on methods. And any class that implements an interface has to fulfill the behaviors, meaning it has to actually define those methods. So it's a way of requiring it, and then they can, they can have slightly different outcomes. You can kind of write them however you want to be specific for that class, but they have to exist and they have to have the same signature. But an interface can have fields as long as they're constants, static final fields. Otherwise, you wouldn't want to ever, share any values coming out of an interface. Method signatures. So this is just like the abstract methods that we were doing in abstract classes last class. But you don't have to use the abstract keyword. It's just abstract by default. The fact that you have given a method signature with no body in an interface means it's abstract. Boom. And static methods can be written as long as there are no references to any instance fields or methods, because again, this is not a case of instantiation. It's just a case of something that's static. So this default methods, you really only use these in special circumstances. Your book gives you a good example where maybe you already have a pretty broad system. You've got an interface that's been applied to a bunch of classes, and you want to come in and write something new, but you're not going to go in and define those in every single class. If that happens, you can actually designate it with a default keyword, and then it allows you, like, it doesn't require it of all those classes now, but you really would want to be very, very careful about how you do that. In general, the purpose of an interface is to enforce something being included in a class. So you're going to want to just, keep them either abstract or static. But all interface fields and methods are public by default. You don't have to use the public keyword, they just are. Okay, so interfaces, to get to the syntax of an interface, a class can only extend a single base class, but it can implement multiple interfaces. And actually don't have an example of multiple interfaces being applied, but you can do that. So you could say implements, this interface implements that interface. You can have as many of those as you need, but you can only have one extends for inheritance. So this implements keyword assigns the interface, and again, it ensures that the class has to define all behaviors, but the class uses override to do that, just like we've done previously when you have something that is being required because it's part of something else. But then you're doing a very specific definition for just that class. So I've got these examples here. Oh, I have one more bullet point. There we go. Unlike an abstract class, it can be applied to multiple classes that are unrelated. And we're going to talk in a minute about, all the differences between the two. But that is a big one. So in this example, I'm using this keyword implements on two completely different classes, used book and merchandise, to implement the same interface, discountable. And there's actually going to be multiple methods that this is going to have, but here's one of them: apply % discount. So I've given up here in the discountable interface definition, I've given the this method a signature, but not a definition, right? So this is abstract. So it basically just means, any class that implements discountable has to define this. So we'll have to go into used book and define apply % discount. We'll have to go into merchandise but it's a great way to make sure that they all get the same behavior with whatever little tweaks you need to offer. So we're going to code that out in a minute. Okay, so just to kind of outline the differences between an abstract class and an interface. Abstract class is about inheritance, right? And use extends for that, whereas an interface, you use implements. Again, you can only have one inherited class, but you can have one or more interfaces being applied to a class. You can have all types of fields in an abstract class with values and such, but you cannot have that. You only can have constant static final fields in an interface. You can only have instance methods in abstract class, because again, that's something that even if you can't instantiate something from an abstract class, because you can't, you can define things related to the instance fields that anything that inherits from that abstract class is going to use. So it's totally okay to set those up. But you can't do that with an interface. You aren't referencing any sort of instance, anything. So because of that, you can have static methods, you can have abstract methods in both. And the usage, again, just to kind of, if it helps you, abstract classes specify various behaviors for related classes through inheritance. But interfaces specify related behaviors for unrelated classes. So it's a matter of what they have in common. So the last couple things to touch on here before we get to the code and demonstrate some of this will be unit testing, which really, this is just like it is with inheritance. You don't test the interface directly. You test the class that implements the interface, and then you just write these tests that make sure that anything that's been required by the interface has been defined and it's working as intended. And we'll do a couple of those too to kind of show you how that works. So this IntelliJ generator has this great thing that once you actually have designated something as implementing an interface, you have some extra things in your little generate menu here, and one of them is implement methods. And all you have to do once you have selected them and it throws that code in, as you can see, it opens it up and just says, okay, here they are. And then all you have left to do is to define them inside the body there to customize it for that class. Okay, do we have any questions about anything I've just talked about? Because I just kind of ran through the slides before we move into the coding. Ben.
I just wanted to know, why did you say you could only do one extends per interface? Like, what was the reason?
One extends per class for inheritance, for class inheritance. You can do multiple implements for interfaces. That's the syntax. It only allows you to inherit one class. Saran? You're muted.
Sorry. Yeah, now you can hear me?
Mhm.
Okay, when I was trying to implement two interfaces in the exercise problem in a book, it created me an error saying that you had to introduce only one interface.
Okay,
In the
interesting.
FigJam.
Yeah, I haven't tested that. And if we have time, maybe I could test that with the stuff I've got set up for this. But if not, maybe I could cover it in the studio review instead. Because yeah, neither of those have examples built in, but we might be able to test that out and see. Yeah. Okay. All right. So let's move over to first yeah, let's do the FigJam first. And I'm going to preface this by saying, don't freak out because we are not coding most of this. I have most of it already coded. Okay. But because it's big. But here's the thing, guys. Here's the thing about this. When you guys get your first job, you're going to go into the job and you're going to look at the code base and you're going to be so lost because it's massive. There's so many files and so many subfolders, and it can be really, really overwhelming. So I'd like you to dip your toe into this because this is nothing like what I'm talking about, but it's a little more complex than most of the things you're looking at most of the time. And I don't want you to get bogged down by it, but I want you to be curious, explore it, try to get your head around it, try to understand how everything fits together. So I'll explain this though, because I know you guys are new at this diagramming stuff. We have an abstract class product. It is kind of the big granddaddy class that we've got going on here. Book inherits from product, as you can see here with this arrow pointing at it. So it gets all these fields, name, description, original price, current price, quantity, but it adds author, genre, format, and number of pages. And then there's another subclass that inherits from book because we have one more thing we want to add, which is what condition is the book in. Meanwhile, over here, we've got merchandise, which is a completely different class that inherits a few things from product, the abstract class, but then it's going to kind of create its own family over here of things. So it adds on, category. I think I ended up taking category off, but it adds theme in the code anyway. Then you have all of these subclasses of merchandise, and guys, there could be so many, right? Oh, and by the way, this is like a bookstore. In case you didn't figure this out, this is not a library. I know I have a book class again, but it's not a library. This is a bookstore. So you have a book department, you have a merchandise kind of, little shop, right? With all these different things. So drinkware, you got your mugs and your, thermos type things. Then you've got calendars of different kinds and, apparel. You could have shirts and hats and whatever. And there could be so many other things, right? Journals, notebooks, pens and highlighters. You could have all these different things. And each of them might have very specific things that they need to be able to store. But ultimately, they're inheriting things from product, they're inheriting things from merchandise. And so they've got everything you need for it to all fit into one big system where you can have a lot of different products all kind of in the system, right? That's kind of the concept here. So to talk about interfaces, here's the business requirement from the owner of this bookshop. He has no intention ever of discounting regular books, new books. However, he would like to discount used books, and he would like to discount it, have the ability to discount merchandise of any kind. So we have this interface that's going to, and you can, oh, wow, I didn't update that either. You know what? Fix it. You can ignore that one. That no longer exists. Apply % discount, apply flat discount. And then remove discount to take it back to the original price. And this will manipulate what this current price field holds as opposed to the original price. And we are only going to implement it in used book and merchandise. And then of course, all of these other subclasses of merchandise will automatically have that same functionality because they are inheriting from merchandise. So I've got these, dotted lines here pointing to show that this is an interface being implemented. And it completely bypasses product and book because we don't want these things to be available to books and to products themselves. To anything else, we only want it to be available to used book and merchandise. So this is a great way to have that be required of both of those, to have them make sure they have the exact same name for their methods. and the same signature. But they can be defined a little differently. And we're going to see that because the thing that's going to be different about these is that merchandise can have a discount applied, but it can't have another discount applied on top of that. So if you try to go back and apply another discount, it's going to take it off the original price and not the current price. Whereas used books, this guy is like perfectly fine with like adding on the discounts. So we're going to define these a little bit differently so that it keeps taking the discount off of the current price and not the original price if you have additional ones. So yeah, again, I know it's a lot, but I'm going to focus in on this, this discounting stuff. We're just going to talk about the interface portion. And you can feel free later to go into this code base once I give you, have it all there for you and explore kind of how I've set up all this other stuff. Grant, you got a question?
Yeah, I see that the return type is void on the interfaces methods. And I was just wondering if the thinking behind that, like, why wouldn't it be a double? And is it like so that it can interact with multiple classes that might not be returning a double? Or why return void on those?
Typically, if a method returns void, it's because it changes the value of a field that already exists, and you don't need to return a value to do that. You just go and say, set the new value of this field to this now. And that takes place inside the body, but there's no need to return a value. It's not you're just saying, go do this, not retrieve a value for me.
That makes sense. Thank you.
Yeah, that's the way I've set these up. Yeah. Okay. So let's go ahead and get into the code here. And we actually have some to-dos I've set up. These are all always so small that I have to make them bigger so you guys can actually read them. So we have here, here's the structure. I'll kind of close this for you. We've got our main method. We've got that product abstract class that everything inherits from. Although that's not, that wouldn't be required. We could apply our interface to something that doesn't inherit from that at all. This just happens to be the way I set it up. I've got a utils thing here that's got a little round to the nearest penny kind of thing to use for our discounting. We'll use that in a bit. Inside books, you've got the book class, which passes along a bunch of stuff to used book. And then you've got merchandise, which has merchandise that passes things on to apparel, calendar, and drinkware. And they all have, their own unique properties as shown, on here, right? Calendar has number of months and format. Apparel has sizes and colors. Drinkware has material and ounces. They each have their own flavor. But ultimately they're, inheriting. Before I move on to the interface stuff, there's two things that I wanted to point out to you guys. About inheritance to kind of tack on to some stuff from last week and to clarify one thing. Let me get this product open. Okay, so product has the most properties defined that then get, passed down to everything. And something we did last time was we had these, two-string methods that we were requiring, and of course in the abstract class, I actually made it abstract with no definition. In this case, I'm actually giving it a definition. And the intention here is that every unique, type of product that inherits from product will actually use this and then add on with whatever additional fields that they are having. So we're actually going to basically make this like a cascading thing where everything will ultimately pull from the one that is just above it in the tree. And so we'll always see this starting off. But the way that we do that is merchandise, which extends product and has, I guess I did have category. I thought I did away with that, but apparently not. Okay. That's interesting. So then you have the two-string here. You'll notice the very first thing that I'm doing is returning super two-string. So I specify that I want to go grab the toString method that's coming from the parent class here. So that's going to mean that it's going to give me all of the lines, wrong one, product, here we go. All of these lines, which, you know, each of them have new lines in front of them. So they're all going to be in a different line. And then it'll actually add on to that with 2 more. And then if I have a product like apparel, I do the same thing. I say, you know, this is inheriting from merchandise. So I'm saying I also want sizes and colors tagged onto that. So apparel is going to have, you know, everything from product, everything from merchandise, plus these 2. So this is an interesting way to use the toString method to get a kind of cumulative way of presenting the information without having to code it all every single time. You can actually just call the toString method of the parent and then just keep passing it down that way. So I wanted to point that out to you because it's kind of a different pattern than what I demonstrated last class. The other thing I wanted to point out is, let's see, where do I have an example of this? Where do I have an example of this? I guess we might have to get into it as we're writing the methods for our interface. So we have this discountable interface that we want to create so that we can implement it on the classes. So the first thing to do is to create the interface itself. And then we just want to give the signatures for these 3 so that they're abstract, and that means they're required by everything. So this should be pretty straightforward. I'm going to come over here and I'm going to actually just put this directly in the class 7. Let me make sure that I am in the right branch before I do this. Yeah, okay. I'm going to put these in the class 7. And you say add class, but then you change it here to interface. It's a different type of file. And we're going to call this discountable. Okay. And we just need, so, you know, it uses, instead of class, it uses interface as the keyword there. And then all we do here is just apply declare each of these. That's what I'm trying to say. So we're going to say apply %discount is going to be the first one. And we're going to require it to give us an argument that is %. And that's it. No body. And then we'll do the same thing here for apply flat discount, double amount. And then we'll do the last one is remove discount to, you know, so that it'll have a way to, and, you know, you might say, well, if you're just changing it back to the original one, regardless of which class it is, you know, why can't you just, well, because that depends on tapping into instance fields, and we can't do that from here. It's an interface. So we will define that even if the definition ends up being pretty much the same in 2 different things, we can't define it here if it's manipulating values of an instance. So we have to just give this you know, basic signature and then actually define it in the classes. All right, so we've got this now, so we can head over to let's start with used book. And the first to do here says to implement the discountable interface. So right after extends book, we're going to say implements and then discountable. Okay, it has imported it for us, and now it's complaining because it says, you know, this needs to either be abstract or it needs to implement the abstract methods from discountable. No problem. So we'll come down here where this to do is, and we'll do that. And I will demonstrate for you how the generator works. This is pretty cool. So you can go into here and say implement methods, and it already has all 3 of them highlighted for me. So I just say, okay. And right there, we've got our override annotations and we've got the signatures of each one. All that's left to do is to actually add the specific definitions of this. So let's do that. Apply %discount. You know, we're taking in a %, and I had this thought. I was just like, okay, people always like, you know, with percents, you kind of never know, is it supposed to be the like round number, you know, or is it supposed to be the decimal version? So I decided to handle this as a little bit of an edge case, to just say if percent is greater than 1, then we want to actually set percent by dividing it from itself, dividing 100. And that'll just, you know, give it a new value. So now it's the decimal that we need it to be. Okay. So I'm going to establish a little local variable here, new price. And I'm going to say that it's get current price. And I want to multiply that by 1 minus the percent, so that it gives us whatever's left over after the discount's taken. And this is where I want to actually point something out to you. Last class, I was using the super kind of, you know, reference every single time on every single method. You don't actually have to do that. If you don't have an alternate definition here in this class that's overriding it, you can actually just tap directly into it because you can see here when I highlight this, it says it's coming from product. So we've got used book inheriting from book, which inherits from product. So that, you know, this is a granddaddy, you know, method here, get current price. But it's okay because it knows that it belongs to this class as well now. However, if I do choose to use super, I can do that and it's the same thing. It's no problem because then I'm just tapping into book, which is, you know, tapping into product. So you can actually, you know, make it simpler just by doing this. Okay. So set current price. And we want to actually, this is where I'm going to use my utils function to say round to penny to make sure that it gives us a nice number. And we'll set that new price into that. And now the current price should reflect the discounted price. So that's good, but I'm also going to add something that prints to the console for us to tell us what we did. It'll make it easier for kind of following what we do in the main method later. So I'm just going to throw this in here. So I'm just basically saying if the price is the current price, then that means nothing's been discounted yet. So we'll just say, you know, a discount of, you know, this percentage has been applied. And, you know, if it already had been discounted, I'll say an additional discount of this has been applied. And I probably could have made that a little bit drier, but that's okay. So we're good on the percent. Now let's do the flat discount. We're going to do something, you know, kind of similar here, but this is much easier because we're just subtracting. So I'm just going to say set current price and just say get current price. Oops, wrong one. Get current price. And subtract by the amount because it's just, you know, a dollar amount. So the math is done. All that's, you know, left to do is just put in our whatever we want to log to the console to kind of follow what it is we're doing. And here again, if it's, you know, the original price discount, otherwise it says additional discount. And then the last thing is just to remove the discount and set it back to the original price. So I can just say set current price and get original price. And then it'll set that value. And I can just, you know, print a little something to the console that just says, yep, it's been set back. You know, and it gives me the ID of the product and the name and, you know, what the original price is, was that it is now. Okay. So we can test that out in main. Trying to remember if I have, yeah, they're in the opposite order though. Oh, I forgot to do this part. Okay, so yeah, I also meant let's do this and then we'll go back. I meant to actually demonstrate for you about the casting thing with inheritance. We have you know, this book I've created, Fahrenheit 451. Remember that from the slide. So here's where we actually, you know, try to access the getter by, you know, like I can try to print, you know, Fahrenheit 451.get condition. And you'll notice that it doesn't know what to do with that, right? Because this has actually been declared as being of type book. So even though get condition is part of used book, because this was actually created as the type book, it's having trouble accessing it. So instead, we can just do, and this is where all the parentheses come in. So we're going to cast this to used book and then say Fahrenheit 451. And then we can call get condition, and there it is. So it was just a matter of casting to the class that actually defines this, and then it works. Okay, so back to our regularly scheduled programming on interfaces. We can do these in any order. It's okay. Let's do used book first. That's fine. So I've created a used book here, and these have incredibly long signatures now with everything they've inherited from all these other classes. So I did this ahead of time. You're welcome. And all we're going to do is actually apply the discounts, the part that the interface required, right, that we just defined. So in the instance here of this used book, we are going to apply a flat discount of $2, and then we'll print it, and this should say book. And so we are going to just go ahead and say P&P for Pride and Prejudice, and then say apply flat discount and give it 2. And then after that, we'll print it. And I'm just going to print the entire book so you can just see the entire list. And this is a good way to demonstrate how that 2-string method keeps building on itself from all the inherited classes. So let's give this a run. Here we go. Okay. Okay, so we are down here. So the first time I printed it, because I printed it after I created it, you'll see that the original price, let's see if I can get this up for you. The original price and the current price are the same, right? When we first instantiate it. And then I come back and say, you know, an additional, additional discount. It shouldn't have done that. There's something wrong with my, oh, it's because of the order in which I did things. Ha, I'll fix it. Okay, of $2, that's not formatted very well, but that's okay. Has been applied to this product, Pride and Prejudice. And then we see that it actually, the current price is $2 lower. So that worked. Okay, let's go fix my logic in this because I did not notice that before. Yeah, so we actually need to set the current price after we print the console, because otherwise, if it's gone ahead and changed it, it thinks that it was, you know, a previous discount. That's the problem there. So I'm going to move these to the bottom. And I might as well move this too. Keep them together. Okay. Yeah, that's better. So that way it's checking the current price before we actually change it to decide whether, you know, it's going to print this or this. Okay, so that should work. So if we run back and I run that again. Yeah, discount of $2 has been applied to product 3. Okay, so now we go back and we say, you know, I want to, let's get back to main. I want to apply another % discount, and this is where we're going to demonstrate that it will actually compound those discounts. So I'm going to say PNP.apply % discount this time, and I'm going to say, you know, 0.5, and then I can print it again, and we'll run it again. Yeah. Additional discount of, you know, oh, it says 0.5%. That's my bad. I should have multiplied that by 100. See, kinks I need to work out, guys. This is the process of development, by the way. But yeah, you can see that it's actually said the original price was $8, but the current price is $3 because it actually was, you know, calculating that 50% off of the $6 from the previous discount. So, you know, just a little bit of things, something to make it interesting and a little different, because when we get over to merchandise, we're going to do it a little differently. While I'm thinking about it, I'm going to fix this stuff though. Awesome. My car alarm is going off in the backyard. That's fantastic. It does that from time to time, and I don't know why. For no reason. Okay, so right. So I actually want to say percent times 100 here. Oh. And then that should work. And then here, and that should be amount. Oh, no, amount is the same because that's a flat amount. Right, okay. All right, let's run it one more time and I'll make sure that it came out the way I expect it to. Discount of $2. Yeah, additional discount of 50%. There we go. So so that looks nice. That works. Let's go over to merchandise, and we're going to do the same thing. We're going to implement it here. Discountable. And you can see that it went ahead and imported it for us here since it's in a different package. And here we'll use our generator to add these in, and then we're going to define them. But we're going to define them a little differently. So we will, I mean, part of it is going to be the same. This part is the same. You know, we adjust it and then we can set the new price. Sorry. Wow. Calculate the new price and then set the current price is what I'm trying to say. Yeah. Okay. Utils dot round to penny and then give it new price. Yeah, that's what we're trying to do. Okay. So there again, that's great, but we're actually going to put our logs to the thing here. I'm going to replace this with percent times 100. So that'll read better. Okay, cool. And then for the, really the flat discount is virtually the same, but again, the message is different. I mean, we're going off of the original price now and not the former current price. So, no matter how many times you add a discount, it's always going to actually calculate this off of the original price now. That's one primary difference between merchandise and new and used book. And then of course, we also phrase this a little bit differently, like original discount has been replaced. Or maybe we should say like, previous discount has been replaced or something like that. Yeah, is maybe a better way to say it. And then remove discount is virtually the same, I think. I'm pretty sure this is just the same, but there again, it references instance methods. And so therefore, we can't actually define it in the interface. We define it here, even if it's the same as it is elsewhere. Okay, so let's go over to main and work this out. We're going to do something similar here. I have created a Harry Potter scarf. The description is join Gryffindor house, wand not included. And so I've got all of the information thrown in here. It's got red and yellow and all this stuff. It's, one size fits all and all that stuff that's required. So now we're just going to focus on what we're doing here with this interface. So same thing, we're going to say, HP scarf, and we'll say apply a flat discount. And we'll say, $3. And then after we do that, we'll print it and view what the changes are with the properties. And then here, we'll just do this all at once. We're going to apply the percent discount and apply the 50% and then print it again. So we'll go look at these in succession, when it's first instantiated, after we take the $3 discount, and what happens after we say we want a 50% discount. So let me run it. All right. So if we come back up here, we've got this Harry Potter scarf. Original price $15.99, current price $15.99. Previous Oh. Okay, apparently I've got a logic issue there too. Maybe I put things in the wrong order again. I think I did, because I think I just copied it all in. I'll fix it. So previous discount, but it says that the discount is $3. And so we see that with, $12.99 instead of $15.99. And then it tells us discount's been replaced with discount of 50%. And so now we see that it's, got this current price set as $8, which is half of $15.99, not half of $12.99. So it definitely did its job of, replacing it or calculating the discount based on the original price and not on the current price. So it's different from used book in that way. We've taken similar behaviors and applied them in unique ways. And that's what interfaces do for us. So let's go back over to merchandise and figure out what I did here. Oh yeah. I accidentally forgot that this needs to go last when I copied and pasted it over. That's all. So I think that covers all of the stuff in terms of just demonstrating how an interface works. The last thing to do here, and we are almost out of time, so we'll do this quick, is to go over into the tests here. I've actually created a couple of tests already. And you'll notice that, let's see, did it? Oh no, yeah. I've got this stuff in here where I'm applying the discount. So the way I basically said this is I just need to test that this stuff, exists in the class and it's been applied properly. So we're just gonna, do a test, can it receive a percent discount? And so I wrote a little spec that describes that, a new used book object can be given a percent discount through the discountable interface. That's a nice, very particular description for this test. I applied the discount. I said, I'm expecting to see $6 based on the fact that the original price was $12. But we're going to go get what actually comes out of it. So we'll run it and find out what the current price is now that we have applied the discount. And then I just assert equals. Now you may notice there's a fourth argument here. That's because when you are working with doubles, assert equals actually requires you to give a delta, a difference, saying that, it's okay if the response is within this many decimal places of, the other one. So that way the tests aren't flaky if you have something calculated, because again, we've talked about this when we talked about the difference between floats and doubles, right? That calculations, very, very precise calculations are difficult to get. There's some other classes out there that you can use. But this allows you to kind of, specify that. In my case, I've got some pretty simple math going on, so I just left it as 0, but that's why that's there. Okay, so I did the same thing with flat discount, applied, $2, said I expect to see that it's 10. And notice that I did put this in a before block so that it's going to instantiate this freshly every single time. So we don't have to worry about these we're manipulating the same thing over and over again. It's actually a new book every single time. So now we just want to, write a test to demonstrate the compounded discounts. So I can kind of say, I want something that's very similar to this, right? And I'm just going to change it to say multiple discounts. Multiple discounts through the discountable interface. And then I'll say apply a flat discount, and then I'll do, actually, let's just do this. Boom, boom. Apply a percent discount. And then we would say, okay, if we took off $2, that brings us to 10. If we take off 50%, that brings us to 5. So we would expect the value of the current price after both of those discounts now to be 5, because we can have multiple discounts with the used book class. So let's run these tests and see where we are. I forgot to mark it with tests. No, I did. I actually forgot to copy the annotation. Therefore, it did not know that the test was there. Let's run it again. Easy mistake to make. Okay. Yeah, and all 3 passed, so we're good. And then we wanted to write a test just to demonstrate that something can be removed. So let's say can remove discount. And a new can have its discount removed. And then we'll say we can apply both these discounts, that's fine. But then we want to say that if we call Horton dot remove discount, then we expect it to be back to $12 as it originally was. So let's run these again now. Yeah. So and you can see all of the logs, coming out as those things were running the code. And it, finished with, I actually don't see my other log. Oh, it's here. It's just because it did it in different orders. This is the thing about tests, right? They're randomized. So even though I wrote that test last, it actually ran up here. So it applied the $2, it applied the 50%, but then it says, it's been reset to the original price of 12. So there we go. Okay. So I realize that's a lot, but I got to get you guys over to Studio. And so let's move along. Hopefully, this is just helping you to kind of solidify your understanding of inheritance. And now with interfaces dropped on, kind of see how those two can work together to, really handle a lot of functionality. Okay, so your Studio, spinning the disks, CDs and DVDs, they look the same. They are not. So there's actually a repository for this for starter code for you. And I think I do actually have a slide about this. Hold on. Yeah. But you're not going to start with the code. You're going to do some thinking and try to decide how you want to design your interface, how you want to define some things and apply them to your CD and DVD classes. You should, it's going to instruct you here to create a, abstract class, optical disk that will, have some things that they do have in common that they can inherit. And then, but they'll have some things that are different. So then you just have to, code the abstract class, complete the disk classes that are already there for you, and then implement your interface that you've created. And then you'll just put some stuff in main to run things. And it does have some bonus missions if you have time to get to them. Again, these sometimes these can be a little bit of ambitious for your Studio time because you're having to think and design things before you actually get into the coding. So you can kind of, look through and read this and, decide if you want to grab, jump into that and get a little bit extra practice, which I always recommend if you have time. So go ahead and, head over. And this is clearly out of date. Sorry about that, guys. I forgot to take class 7 off. But yeah, so Monday we'll talk about Spring, controllers and routing, and then you'll have your catch-up class Thursday. So head on over to Studio and we'll come back here at 8 o'clock.